Right now, take a moment to look at the world around you. Look at the device in your hands, the light filtering through the window, or the stars if you are outside in the dark. Everything seems permanent. Everything seems solid. You trust that the ground beneath your feet will hold you up. You trust that the atoms in your body will continue to hold together. You trust that the laws of physics are written in stone, unchanging and eternal. But what if I told you that this trust is a lie? What if I told you that the stability of our universe is nothing more than a cosmic illusion? There is a terrifying concept in theoretical physics that keeps scientists awake at night. It is not a rogue asteroid the size of a city hurtling toward Earth. It is not a supervolcano waiting to choke our atmosphere with ash. It is not even a wandering black hole drifting through our solar system. Those are physical threats. We can see them. We can track them. We can calculate their trajectories and perhaps, with enough time and technology, we can deflect them or hide from them. But the threat I am talking about today is different. You cannot see it coming. You cannot hide from it. And most terrifying of all, it might have already happened. Consider the sun. It is 93 million miles away. If the sun were to suddenly explode or vanish this very instant, you would not know it. You would still see it shining brightly in the sky. You would still feel its warmth on your skin. The flowers would still turn their heads toward it. For 8 minutes and 20 seconds, life on Earth would continue exactly as normal, completely ignorant of the fact that the source of all life has already died. We live in the past. We see the universe as it was, not as it is. Now, expand that terrifying delay to the entire cosmos. Somewhere, a billion light-years away, or perhaps just outside our solar system, a bubble of pure destruction could have formed. A bubble where the fundamental laws of physics have suddenly snapped. This bubble expands at the speed of light. It does not burn things, it deletes them. It rewrites reality. And because it travels at the speed of light, it gives no warning. We would not see a flash. We would not hear a sound. One moment, we are here, wondering about our place in the universe. The next moment, we are simply gone. The atoms that make up your body would disintegrate. The chemistry that allows your brain to think would cease to exist. This is the scenario known as false vacuum decay. It is the ultimate cosmic reset button, and the scariest part is that mathematics suggests our universe is primed for it. If you want to understand the universe and the terrifying fragility of our existence, make sure you subscribe to the channel. We explore the darkest corners of the cosmos where others are afraid to look. Join us, and let us face the void together. To understand why the universe might delete itself, we first have to understand what holds it together. We have to talk about the foundation of reality itself. For centuries, humans believed that space was just an empty stage. A black void where stars and planets performed their dance. But modern physics revealed that empty space is not empty at all. It is alive. It is vibrant. It is filled with invisible fields that permeate every single centimeter of the universe. Think of these fields like the air in a room or the water in an ocean. You cannot always see them, but they determine how everything moves and interacts. There is an electromagnetic field that carries light. There are fields for electrons and quarks. But there is one field that is more special and more mysterious than all the others. It is called the Higgs field. Imagine a universe without the Higgs field. In this hypothetical reality, particles would have no mass. Every electron, every quark, every piece of matter would zip around at the speed of light. They would never slow down. They would never bond together. Atoms could not form. Stars could not ignite. Life as we know it would be impossible. The universe would be a chaotic soup of radiation, a place where nothing ever stays still long enough to become something. But our universe is not like that. Here, things have weight. Things have substance. And that is entirely thanks to the Higgs field. Think of the Higgs field like a thick, invisible cosmic molasses that fills the entire universe. As particles move through this field, they have to push against it. This resistance is what we call mass. Some particles, like photons, slip through the molasses effortlessly, they have no mass and travel at light speed. Others, like electrons and quarks, get bogged down. They interact heavily with the field, gaining mass and slowing down. This slowing down allows them to clump together. It allows gravity to take hold. It allows stars to form galaxies, and atoms to form you. The Higgs field is the anchor of our reality. It is the reason we exist. But there is a catch. A very dangerous catch. For the Higgs field to do its job, it has to be stable. In physics, everything seeks the lowest possible energy state. Think of a ball rolling down a hill. It will roll until it reaches the bottom of the valley and stops. Once it is at the bottom, it is stable. It will not move unless something pushes it. This is what we call the vacuum state. The word vacuum here does not mean empty space, it means the state of minimum energy. We have always assumed that the Higgs field is at the bottom of the valley. We assumed it had settled into its most stable, permanent configuration billions of years ago, shortly after the Big Bang. We believed we were living in a true vacuum. A true vacuum is a universe that is completely stable. The laws of physics are fixed, and they will never change. In a true vacuum, the ball is at the absolute bottom of the lowest valley in the landscape. There is nowhere lower to go. But there is another possibility. A possibility that haunts the equations of quantum mechanics. What if the ball is not at the bottom? What if the ball is stuck in a small dip halfway down the mountain? This is called a false vacuum. To the ball, it feels stable. It is not rolling. It seems secure. You could build a civilization on that ledge. You could evolve life, build cities, and study the stars, never realizing that you were living on a precipice. But just over the ridge of that little dip, there is a sheer drop. A drop into a much deeper valley. A valley with a lower energy state. If the Higgs field is merely in a false vacuum, it means our reality is not the final version of the universe. It means we are living in a temporary state. We are balancing on a tightrope, and we have been doing so for 13.8 billion years. The problem is, until recently, we had no way of knowing which valley we were in. We could only guess. We needed to measure the mass of the Higgs boson, the particle associated with the Higgs field, to find out the truth. For decades, the Higgs boson was just a theory. It was the God particle, the missing piece of the puzzle. Physicists built massive machines, miles of underground tunnels, and smashed atoms together at near light speed, trying to knock this particle loose so we could study it. Then came the year 2012. At the CERN laboratory in Switzerland, deep beneath the border of France and Switzerland, the Large Hadron Collider roared to life. Thousands of scientists from all over the world held their breath. They were smashing protons together with energies never before achieved by humanity. They were recreating the conditions of the infant universe, just moments after the Big Bang. They were hunting for the ghost in the machine. And on the 4th of July, 2012, they found it. The data spikes on the monitors confirmed it. The Higgs boson was real. Champagne bottles were popped. Nobel Prizes were awarded. It was hailed as one of the greatest triumphs in the history of human intellect. We had finally completed the standard model of particle physics. We had found the keystone of reality. But as the celebrations died down and the physicists went back to their chalkboards to analyze the data, the smiles began to fade. They started to look closely at the mass of the Higgs boson. They measured it at approximately 125 gigaelectronvolts. This number is specific. And it is terrifying. You see, if the mass had been significantly lighter, the calculations would show that the universe is unstable and should have collapsed long ago. If the mass had been significantly heavier, it would confirm that we are in a true vacuum, completely stable and safe forever. But the universe, with a dark sense of humor, gave us neither. The mass of 125 gigaelectronvolts lands us right in the middle of the danger zone. It puts us in a state known as metastability. This is the scientific term for living on the edge of a cliff. It means that the universe appears stable for now. It could last for billions of years more. but it is not truly stable. We are indeed the ball stuck in the little dip on the side of the mountain. The barrier keeping us safe is thin. And on the other side of that barrier lies a state of lower energy, a different version of physics that we cannot comprehend. This discovery changed the tone of theoretical physics. Before 2012, the end of the universe was thought to be a distant, slow event. We talked about the heat death, where stars slowly burn out over trillions of years, and the universe gently fades into darkness. It was a sad ending, but a peaceful one. It gave us time. It gave us a sense of closure. But the Higgs boson revealed a different path. A path of sudden, violent change. It revealed that the ground beneath our feet is not solid rock, but thin ice over a deep, dark ocean. To understand the gravity of this, we have to look at how quantum mechanics treats barriers. In our macroscopic world, if a ball is stuck in a valley, it needs a push to get over the hill. It needs energy. If you do not kick the ball, it stays there forever. But in the quantum world, particles do not play by these rules. They are spooky. They are unpredictable. A particle does not have to climb over a hill to get to the other side. Sometimes, it can simply tunnel through it. This is called quantum tunneling. It happens all the time. It is happening in the sun right now. Without quantum tunneling, the sun would not be able to fuse hydrogen and would go dark. It is happening in the transistors of your computer. It is a proven fact of nature. And if tiny particles can tunnel through barriers, what about the Higgs field itself? What if a tiny patch of space anywhere in the universe decides to tunnel through the energy barrier? What if it decides to drop down to that lower, deeper valley? All it would take is one single point in the vastness of the cosmos. One quantum fluctuation. One roll of the cosmic dice. If a bubble of true vacuum forms, even if it is the size of a single atom, it will not stay small. It will be more energetically favorable than the space around it. It will want to grow. It will consume the false vacuum around it to fuel its expansion. It will push the domain of the old physics outward, replacing it with the new physics. This is the mechanism of our destruction. It is not an explosion in the conventional sense. An explosion pushes matter outward through space. This is an explosion of space. The bubble wall would accelerate instantly to the speed of light. It would possess an energy density beyond human comprehension. As this wall passes through a region of space, it fundamentally alters the properties of the particles in that space. Imagine a painting. Now imagine a drop of solvent falling on that painting. The solvent spreads, dissolving the image, turning the structured colors into a blank gray smear. The bubble of true vacuum is the solvent. Our universe, with its stars, galaxies, and life, is the painting. And the drop might have already fallen. The implications of this are not just physical, they are deeply philosophical. It forces us to ask what reality really means. If the laws of nature can change in an instant, then are they really laws? Or are they just local bylaws, temporary rules that apply only to our specific bubble of existence? We look out at the night sky and see billions of stars, thinking they are governed by the same rules as our sun. And for now, they are. But we assume that these rules are eternal. The discovery of the Higgs mass suggests that the rules are fragile. In the next part, we are going to dive deep into what actually happens when this bubble hits. We will slow down time and examine the moment of impact. What happens to an atom when the laws of physics change? What happens to a human body? And is there any way, no matter how unlikely, that we could see it coming? The science gets even stranger, and the picture gets even darker. And the darkest part of this picture is the silence. We are used to disasters being loud. We associate destruction with chaos, with sirens, with screaming, with the roar of crumbling buildings. But the end of the universe would be perfectly silent. It would be faster than the nerve impulses traveling from your eyes to your brain. You would literally cease to exist before you even had the chance to realize you were dying. Let us try to visualize this monster. In physics, we call it a nucleation bubble. Imagine a pot of water superheated in a microwave. It is hotter than the boiling point, but the water looks calm. It is perfectly still. It is metastable. Then, you drop a single grain of coffee into the cup. Instantly, the stability breaks. The water erupts violently, flashing into steam. The universe is that superheated water. The grain of coffee is the quantum fluctuation. And the steam is the new reality expanding outward. The edge of this bubble is a domain wall. It is a shell of high energy that separates the old universe from the new one. This wall has tension. It has power. As it expands, it releases the stored potential energy of the Higgs field. This release of energy accelerates the wall outward until it hits the cosmic speed limit. This speed limit is the cruelest part of the trap. In our universe, information travels at the speed of light. If a star explodes, the light from that explosion travels to us at 300,000 kilometers per second. We see the event happen after it has happened. But the wall of the vacuum decay is also traveling at 300,000 kilometers per second. It is riding the leading edge of its own warning signal. The light from the destruction and the destruction itself arrive at the exact same time. Imagine you are looking at the Andromeda galaxy through a telescope. It is 2.5 million light-years away. If the decay bubble started there today, you would see Andromeda shining beautifully in the night sky for 2.5 million years. Generations of humans would rise and fall. Civilizations would crumble and be rebuilt. We would look up at Andromeda and write poems about its beauty. And then, one ordinary Tuesday night, the wall would arrive. There would be no visual change in the galaxy beforehand. No dimming stars. No warping of space. Just an instantaneous deletion of Earth. We are effectively blind to the executioner's blade until it touches our neck. If you enjoy these deep dives into cosmic horror and the fragility of existence, please take a second to hit the like button. It helps the algorithm find other truth seekers like you. And let me know in the comments, if you knew the world was ending in exactly 1 hour, would you tell anyone, or would you let them enjoy their final moments in peace? Now, let's cross the threshold. Let's imagine we could somehow slow down time to a crawl and watch what happens when that wall hits a single atom. Let's take a nitrogen atom in the air you are breathing right now. It has a nucleus of protons and neutrons, and it has electrons buzzing around it in specific shells. The reason those electrons stay in those shells is because of the mass of the electron and the strength of the electromagnetic force. These values are determined by the interaction with the current Higgs field. As the domain wall passes over this nitrogen atom, the value of the Higgs field changes instantly. The molasses we talked about earlier becomes something else entirely. Maybe it becomes thinner. Maybe it becomes infinitely thick. Or maybe it vanishes completely. The properties of the electron depend on this field. In the new vacuum, the mass of the electron might suddenly increase by a factor of 1,000,000. Or it might become 0. If the electron becomes heavy, it crashes into the nucleus. The atom collapses on itself. Chemistry becomes impossible because electrons can no longer be shared between atoms. Bonds break instantly. The molecules that make up your DNA, your cells, the concrete in your walls, and the water in the oceans would all fall apart. Matter as we understand it would dissolve into a dense, unrecognizable sludge of heavy particles. On the other hand, if the electron loses its mass, it flies off at the speed of light. The atom simply disintegrates into radiation. There would be no solids, no liquids, no gases. Just a bath of flying particles. In either scenario, biology is the first thing to go. Life depends on complex, delicate chemistry. It depends on carbon atoms holding hands with hydrogen and oxygen in very specific shapes. False vacuum decay does not just break the chain, it erases the concept of the chain. But it gets worse. The change in the Higgs field would likely affect the other fundamental forces as well. The strong nuclear force, which glues protons and neutrons together inside the nucleus, could be altered. If this force weakens, every atomic nucleus in your body would unbind. You would not just turn into sludge, you would turn into a cloud of protons and neutrons, which would then likely decay into even more fundamental particles. We are talking about the total dissociation of matter. And what about gravity? The energy released by the bubble wall is immense. As the bubble grows, the interior has a lower energy density than the outside. In Einstein's general relativity, energy and mass warp spacetime. A sudden, drastic change in the energy density of the universe would create gravitational shockwaves of apocalyptic proportions. Some theories suggest that inside the bubble, gravity could become repulsive. Instead of falling down, things would fly apart. Or, gravity could become so strong that the entire interior of the bubble instantly crunches down into a singularity, a universe-sized black hole. So, the question naturally arises, what triggers this? If the universe is a minefield, what steps on the mine? We mentioned quantum tunneling, which is a random, natural process. It is a roll of the dice. It could happen anywhere in the deep void between galaxies. But there is a darker, more unsettling question that scientists have asked. Can we trigger it? Can intelligent life, in its arrogance, accidentally push the button? This brings us back to the panic of 2008, before the Large Hadron Collider was switched on. There was a legitimate lawsuit filed in federal court to stop the activation of the machine. The plaintiffs argued that smashing particles together at such high energies might create a mini black hole or, more terrifyingly, trigger a vacuum decay event. They feared that by concentrating so much energy in a tiny point of space, we might punch a hole in the frozen lake of the Higgs field. The scientists at CERN had to publish a safety report to calm the world. They argued that nature is already doing this experiment for us. High-energy cosmic rays from deep space are constantly bombard the Earth's atmosphere. These particles hit us with energies far greater than anything the Large Hadron Collider can produce. They argued that if these collisions could trigger vacuum decay, the universe would have ended billions of years ago. We are still here, so the universe must be more robust than we fear. However, this reassurance relies on a statistical argument. It assumes that the universe is uniformly safe. But what if the stability of the vacuum depends on local conditions? What if we are creating a unique type of dense, focused energy that does not occur naturally in the random collisions of cosmic rays? It is a small probability, infinitesimally small, but when the stakes are total universal annihilation, even a 0.001% chance feels too high. Furthermore, we are only at the beginning of our technological adolescence. The Large Hadron Collider is a toy compared to the particle accelerators we plan to build in the coming centuries. We want to build colliders the size of solar systems. We want to harness the power of stars. As our ability to manipulate energy grows, so does our ability to poke the fabric of reality. We are like children playing with matches in a library made of dynamite. We might not set it off today. We might not set it off tomorrow. But eventually, if we keep striking matches, we might find the one spot where the fuse is exposed. There is also the possibility that we are not the first. Look at the Fermi paradox. We look out into the universe and see billions of stars, but we hear no signals. We see no alien empires. We see no megastructures. Why is the universe so quiet? One terrifying solution to the Fermi paradox is related to vacuum decay. Perhaps, when a civilization becomes advanced enough to understand the Higgs field, they inevitably build a machine that destroys them. Maybe the great filter is not nuclear war or climate change. Maybe the great filter is particle physics. It is possible that the universe is littered with the ghosts of civilizations that reached for the secrets of creation and accidentally triggered their own deletion. A bubble of nothingness that expanded outward, swallowing their home planet, their star, and then silently continuing its journey through the galaxy. This leads us to a strange realization about the geometry of the bubble. If a civilization in a distant galaxy triggered this event a billion years ago, the bubble is currently expanding toward us. It is eating its way through the intergalactic void. It is consuming galaxies, erasing history, and resetting the clock. Because the universe is expanding, and because the bubble expands at the speed of light, there is a race happening. Dark energy is pushing galaxies apart. The vacuum decay bubble is trying to catch them. If the universe expands fast enough, some parts of the cosmos might be safe forever, running away from the bubble faster than the bubble can chase them. We are effectively living in a fragmented reality, where different regions of space might be operating under different laws of physics, separated by expanding gulfs of nothingness. We could be safe in our little island of the false vacuum, while a true vacuum meets the shores of the universe far beyond our horizon. But there is one final twist to the mechanism of the bubble that is even stranger. Some physicists, like Stephen Hawking, theorized about this. It is not just about the bubble hitting us. It is about what the bubble is. Is it just a new state of physics? Or is it something more final? There is a concept called the bubble of nothing. Not just a vacuum with different rules, but a hole in existence itself. A region where space and time do not exist. If the decay results in a geometry that is unstable in a different way, the interior of the bubble could be a true void. No dimensions. No time. No potential for anything to ever exist again. It would be like cutting a hole in the canvas of a painting. The painting doesn't just change color, the canvas is gone. This brings us to the edge of science and philosophy. If the universe can simply delete itself, does it have a purpose? Are we just a temporary fluctuation, a fleeting dream in the mind of a chaotic cosmos? In the final part, we will look at the aftermath. We will explore what lies inside the bubble if it isn't total nothingness. Could life exist there? Could we survive it? And most importantly, I will show you why some scientists think this terrifying event might have actually happened before, and why it might be the reason we are here in the first place. It is a terrifying thought, but it leads us to a possibility that is arguably even stranger. What if this has already happened? What if the Big Bang itself was not the beginning of everything, but simply the moment a bubble of false vacuum decay hit a previous universe? Consider the chaotic energy of the Big Bang. It was a moment of sudden, explosive expansion. It was a moment where the laws of physics as we know them were written into existence. Some cosmologists suggest that our universe is merely the interior of a bubble that formed inside a much larger, older parent universe. That parent universe might have had completely different laws of physics. Maybe it had 10 dimensions. Maybe it had no gravity. And then, a quantum fluctuation occurred. A bubble formed. And inside that bubble, the energy stabilized into what we call protons, electrons, and photons. We might be living inside the explosion. The expansion of our universe, which we observe as galaxies moving away from each other, could be the walls of our bubble still pushing outward into the void of the parent universe. We look back at the beginning of time and see a singularity, but perhaps we are just looking at the nucleation point where the phase transition began. We are the survivors of a previous apocalypse, built from the ashes of a reality that was erased to make room for us. This theory, known as eternal inflation, suggests that the cosmos is like a pot of boiling water. Bubbles form constantly. Some bubbles grow large and become universes like ours. Some bubbles collapse instantly. Some bubbles collide with other bubbles. We might be floating in a multiverse foam, surrounded by other realities that we can never touch or see. In those other bubbles, the Higgs field might have settled at a different value. Maybe in the bubble next door, gravity is repulsive. Maybe light travels at 10 miles per hour. Maybe life is impossible, or maybe life takes forms so bizarre we cannot comprehend them. If this is true, then false vacuum decay is not a glitch. It is the reproductive system of the multiverse. It is how the cosmos refreshes itself. It deletes the old, stagnant universes and replaces them with fresh, new ones with new rules. It is a cycle of death and rebirth on a scale so massive that the human mind struggles to hold the concept. But let us bring it back to us. Back to Earth. Back to the fragile biological machines walking on the surface of a wet rock. If a decay bubble is heading toward us right now, is there absolutely nothing we can do? Survival relies on information. To survive a hurricane, you need to know it is coming. You need a forecast. But as we established, the vacuum decay warning signal travels at the same speed as the death wall. However, there is a theoretical loophole. If the space itself is expanding, and if we are far enough away, we might never be hit. But what if we developed a way to travel faster than light? Warp drives, wormholes, Alcubierre drives. These are staples of science fiction, but they are serious mathematical concepts in general relativity. If humanity could one day build a ship capable of moving faster than light, we could theoretically outrun the bubble. We could stay ahead of the wave of destruction, surfing on the edge of the apocalypse forever. Or, we could escape into a different region of the universe that is expanding away from the bubble faster than the speed of light. But there is a darker implication to warp drives. If we can bend spacetime to travel faster than light, we might inadvertently create the very conditions that trigger the decay. Warping space requires massive amounts of negative energy and extreme concentrations of power. It is possible that the very engine we build to explore the universe becomes the needle that pops the balloon. It is a cosmic irony. The moment a civilization becomes advanced enough to escape their galaxy, they might seal their own doom. So, where does this leave us? We are sandwiched between two terrifying possibilities. 1. The universe is metastable and could end at any second without warning. 2. The universe is stable, but we are trapped in a slow, cold march toward the heat death, or all stars die and the universe becomes a dark graveyard. Which fate is better? The heat death is a long, agonizing decline. It allows for trillions of years of life, but the end is bleak. It is a whimper. False vacuum decay, on the other hand, is a bang. It is instant. It is a clean cut. There is something almost poetic about it. Instead of fading away into obsolescence, the universe goes out at its peak. It is deleted while it is still beautiful. And perhaps, inside the bubble of the new vacuum, something better awaits. We assume that the new physics would be hostile to life. But we do not know that. The new vacuum has a lower energy state. It is more stable. Maybe, just maybe, the laws of physics inside the bubble are even more conducive to complexity than ours. Maybe the new universe allows for stronger chemical bonds, more efficient energy transfer, and forms of consciousness that are far superior to our biological brains. We might be the beta version of the universe. We are the glitchy, unstable prototype. And the vacuum decay is the software update. The bubble of doom might actually be a bubble of paradise for whatever comes after us. We will not be there to see it, of course. Our atoms will be scrambled. But the energy that makes us up will continue. It will be repurposed. It will become part of the new architecture. This perspective shifts the fear into awe. We realize that stability is not the norm. Chaos is the norm. Change is the norm. The fact that we have had 13.8 billion years of relative stability is a miracle. The fact that the Higgs field settled into this specific, narrow valley just deep enough to allow stars to shine and atoms to hold together is a statistical anomaly. We are walking on a tightrope over an infinite abyss, and we have managed to keep our balance for billions of years. We should not be paralyzed by the fear of falling. We should be amazed that we are still standing. Every second that the universe continues to exist is a gift. Every breath you take is stolen from the void. Every time you look at the stars, you are witnessing a delicate balancing act that defies the odds. This knowledge should not make you nihilistic. It should make you present. It should make you appreciate the solidity of the ground beneath your feet, the warmth of the sun, and the structure of your own body. Because now you know that none of it is guaranteed. It is all a temporary arrangement of quantum fields, waiting for the slightest nudge to rearrange itself. We spend our lives worrying about small things. We worry about money. We worry about status. We worry about tomorrow. But in the grand scheme of the cosmos, tomorrow is a luxury. The universe does not owe us a future. It has given us a now. And that is all we can ever truly claim. But while the false vacuum is a theoretical monster that might kill us instantly, there are other monsters in the universe that are very real, very physical, and very hungry. We talk about the universe deleting itself, but there are objects out there that are actively deleting matter every single second. They punch holes in reality. They warp time so severely that it stops. They are the graves of dead stars, and they are lurking closer than you think. We worry about the vacuum collapse, but perhaps we should be more worried about the gravitational collapse. We worry about the invisible energy field, but we ignore the darkest, densest objects in existence. These objects do not just break the laws of physics, they crush them into a single point of infinite density. If you want to understand the true monsters of the cosmos, the ones we can actually see and map, you need to understand the dark hearts of galaxies. You need to understand the one force that fights the vacuum and wins. I am talking about black holes. Most people think they know how black holes work. They think it is just a vacuum cleaner in space. But the truth is far stranger. Did you know that time stops at the edge of a black hole? Did you know that if you fell in, you might see the entire future of the universe pass before your eyes in a split second? If the idea of the universe ending instantly terrified you, then the idea of being trapped in a place where time never ends will haunt you. We have a complete breakdown of what these gravitational monsters actually do to reality. It is not just destruction, it is a gateway to the unknown. Click here to watch our deep dive into black hole basics. Find out why these cosmic predators are the most misunderstood objects in the universe, and why they might hold the key to surviving the ultimate end. The universe is full of traps, and while the false vacuum is the silent killer, the black hole is the loud, violent beast that demands your attention. Do not let your curiosity end here. The cosmos is vast, dark, and full of secrets waiting to be uncovered. We are just getting started. Until next time, keep looking up.